Thanks very much, and thanks for having me. In this talk, I'm going to cover some things that I've become passionate about helping people deal with telemetry coming from the network, even telemetry that helps networkers figure out what's going on that isn't necessarily from network devices. As I said in the question about telemetry and monitoring, I do view that telemetry is where things start. And when we work with people, we see people struggling to collect it and usually wanting to send it to multiple places. Often they have a data lake, often they have internal projects, often they have controllers and they're trying to do automation, and there's no one vendor that you can just focus on and solve the problem. So give a little background. Myself, I started an ISP back in 1992 in Philadelphia when engineering at AboveNet, and then I was at Akamai for 10 years, then a cloud company called Server Central, and then I started Kentic to focus on, we would have said monitoring initially, we'd talk about observability now, but again, telemetry is the food, which analytics works on. Why am I concerned about being able to take wide kinds of telemetry? Why are we thinking about making that actually open source in what we do? Well, there's a lot of types of telemetry when we run the network, right? The streaming telemetry, people don't have flow. Sometimes they have routing, sometimes they don't have BGP. You've got SNMP, which we see in the enterprise networks, as well as in traditional networks. And streaming telemetry is definitely used, but in some ways it's the IPv6. It's not really replacing some of the older technologies because people have devices that they're not going to throw out, again, especially in the enterprise. There's performance testing, which maybe you have a Cisco that can do IPSLA, but if you run other devices, how do you understand not just the traffic, but performance? Of course, there are many kinds of networks, and it's not just ours, right? We may have applications that run in the cloud, or we may be talking to applications that run in the cloud. If you have an enterprise, if you have a portal, even if you're a service provider, it may use Twilio to send texts, SMS to people. Because of the way that we evolved, we've got NetFlow, SFlow, IPFix. We've got, SNMP and streaming telemetry. We have BGP ad paths, BMP, lots of ways of getting BGP, live peering. And then we see people sending data to billing systems and data lakes and their monitoring systems that they use. And so there's a lot of these types of sources from a lot of kinds of devices, some of which, again, like VPC flow logs, come from clouds, and we, the networkers, unless you work for Amazon or Google or Microsoft, you don't control that. We just have to go that network. So we get what we get. So when you're trying to automate, when you're trying to put a dashboard on your network, you have to take all this data and then send it to multiple places. So how do you do that? How do you get the maximum value, out of that? Historically, there are analytics thing per telemetry type. So NetFlow would have one, and routing would have one, and SNMP and metrics, would have one. And generally, you sort of leave it in the machine would emit UDP NetFlow, and something would take it and then store it and do its own thing there. And we'd often leave it as a tool for network people, and that creates problems sometimes when we want to work with application people who, of course, always think that the network is the problem. So to have a conversation at the network level, we want to understand, is that Kubernetes controlling that? Look up in a CMDB, what application is it? And the application people, a lot of them would like to understand what part of the network is this? Is this my network? Is this not? But historically, these things were separate. They were siloed. I think that is changing. What we saw over the last really 10 to 20 years is mostly routers copying their telemetry or being pulled multiple times by multiple systems. But for example, for NetFlow, SFlow, IPFix, for things that are UDP based, there is something called Samplicator that would replicate UDP traffic. So already the idea of creating a bus so that to reduce the load on the router or the switch. For BGP, there's been many projects that capture BGP, whether it's by devices speaking a protocol that's not quite live BGP for it, or speaking iBGP or eBGP to something that then captures these dumps that we can look. And right now, RIPE, CADA, have these archives of BGP that we can use to see the state of the internet from a routing perspective. Over the last few years, really on the streaming telemetry side, there's been some work to try to emit once from the router and send. There's a project called Gmi Gateway from Netflix and Google. Cisco had done something called Big Muddy. Yahoo had done something to put SNMP on a bus to send to multiple systems. But if you look across the kinds of network telemetry, historically, they've all been separate systems. In the application world, there's work towards something called open telemetry, and there are platforms that are trying to solve this kind of pattern, but there hadn't really been something in the network space for it. So what we are seeing recently is a lot of service providers and a lot of enterprise want to take all their telemetry, network, but also application and sometimes business, and put it somewhere in the end. So not only their operational tools, but also a data lake, or sometimes people say a lake house, like a data warehouse that's a data lake. I don't love that term, but in between, with the rise of Kafka, era data buses, the idea of anytime we get telemetry, can we put it on Kafka? Anytime we need to send it somewhere, can we pull it off of that, some sort of data bus, Kafka, Tibco, something like that. We've seen that as a strategy, but then we often see people having to 10 customers in parallel having to say, well, okay, so how do I get BGP in there, and how do I get NetFlow in there, and then how do I send it to something like a Kentic, or to my billing system, or things like that. Another thing we see sometimes is people trying to not use separate analytic systems and just write their own applications on top of a data lake or something. We get a lot of requests of, hey, can't you just use the data in place? But that is a challenging approach for vendors. And for every company to write everything on their own, certainly there are people that do, but that's challenging too. So the pattern of let's have a bus, let's put things on it, let's send things to everyone that needs it, let's make it available to network tools and not, a big fan of. But we saw a lot of people working on their own trying to do this and thought maybe this is an opportunity to help, because some of these things we solved on the commercial side, and decided as open source, as an open project, and trying to get community around it, maybe this is something that we can all help each other solve. As a review of some of those systems, and this link, the deck will be linked, I think, from the talk. These are some of the systems that are standalone to deal with replicating UDP, for sending NetFlow, SFlow, IPFix to multiple systems, analyzing BGP history from CADA with BGP Stream, Yahoo's approach, which is put SNMP on a bus, so stream SNMP as a form of streaming telemetry. Some of the systems that deal with replicating streaming telemetry, as a more recent type, and then K-Translate, which is part of our data bus strategy, from Kentic, is open source and also can replicate and actually shape, roll up, and munge both flow, SNMP, actually also VPC flow logs, and some other things now. But today, each of these is standalone for a different kind of telemetry. Where we're going with this project is to try to have the option of one project that tries to deal with multiple types of network telemetry and send to multiple systems, including things that are not traditionally network systems. And that goes from some of the work that we've done with linking to things like New Relic and Datadog and Splunk and Prometheus and Influx, some of which are used for network people, but also used for application owners and other people in the business. So what I would like to see, and if anyone knows of anything or any projects which we're not listing or aware of, is something that does edge networks, core networks, cloud networks, monitors the internet, has modular adapters for any kind of telemetry, again, especially network telemetry, supporting, I might get something that's S-flow in JSON, in CSV, or in a continuous stream. So that's what I would call a non-network format. It's not a binary format from the IETF supported by a router, but also supporting all the things that routers and switches, and cloud networks emit. To take telemetry and make it usable, it's often useful to put what was the BGP route at the time, what's the IP address, what does my IPAM, my IP address management, DDI, what application, user, company, customer is that on the telemetry, and better to do that at the time of ingest, because the BGP route today may not be the BGP route from 3 days ago when I got the telemetry. And then also be able to transform it, because if you try to put, for example, NetFlow in a time series database, it will explode because they're not really designed for the number of unique, for example, IP addresses, which is called cardinality, the number of unique values. So each data store, each system has sometimes different requirements about how it receives the telemetry. So we'd like to see a system that supports all these things. And in the non-network side, there's been a rise of something from the ETL space, the extract, transform, load side of the data moving space, really formalizing around something called an observability pipeline, which is taking telemetry, collecting it from logs and metrics and traces from applications and systems, sending it somewhere, being able to replicate it, being able to filter it, and then send it to multiple backends. That's not exactly how our project developed. We developed our project just because Kentic customers wanted to be able to send data to Elastic, Splunk, time series databases and things like that. But I think this pattern, if something like this existed for the network world, would be very helpful. And that's what we've started building, again, as an open source project that we'd love to have feedback and collaboration around. So K-Translate, which is the core of it, we developed because people were taking NetFlow, SNMP, BGP, streaming telemetry, VPC flow logs, eBPF from servers into Kentic, having us enrich it. And then they said, well, I have a data warehouse, I need to send this, or I'm building a controller, I need to get this data. So it started as sending from a format we use, but then going to all of those output sources. Then last year, we partnered with New Relic, which is an observability provider. So they focus on analytics, but for application and developer owners. And to send data to them, we needed to reduce the volume, reduce the number of IP addresses, create rollups, do filtering. And when we looked at what we had at the end of that, we realized that we sort of had the beginnings of a pipeline, and maybe that would be useful more broadly. So today, it takes flow data, metrics, SNMP, and streaming telemetry, VPC flow logs, and with agents, which we've also open sourced and are free to use, eBPF and PCAP from servers. For example, something you could run on a DNS server, because if it isn't the network, it's often DNS. Or you could run to copy packets, which I view as mostly an older approach. At modern network scale, that's harder to do. So usually we see people thinking about monitoring, having agents then we added in observability platforms. And I mentioned earlier this idea of network protocols versus non-network protocols. It can output in NetFlow, SFlow, does not output in doesn't output in SNMP today, or as JSON, in CSV or to Kafka, or speak binary protocols to time series databases like Influx and Prometheus. So the idea of take the data, have it in some representation, and then flexibly transform it. The goal is to avoid everyone having to write the input side and output side of trying to build this on top of something like Kafka, and then replicating it so that it can send to multiple places. This really evolved, working with customers, people like New Relic and now Dynatrace, where we're working to send data to observability systems. We borrowed GoFlow for K-Translate, and I'd like to thank Cloudflare as well for that. So with something like K-Translate with a data bus, we have a number of folks in the community or customers that take the same view of data and may use Grafana with Prometheus for primarily metrics, but also taking a view of NetFlow and even BGP data and performance. Or as I mentioned, New Relic, where application owners might want to see, is there a network problem? Is there congestion? Is there a performance issue from the network? Or of course, we send it to Kentic so people can do more network-centric workflows around analytics. We distribute it as a Docker, and I have the link in here. So we distribute it as Docker. It's also code that you can compile, and you can run multiple daemons. We are building some work that I'll talk about to make it so that you have config files. And today, this is a standalone binary. We don't have as good, ironically, telemetry on the telemetry system. So right now, K-Translate is just starting to emit telemetry about how it is performing and doing, which is important if people really want to operate it at scale. So those are things that we're working on right now and funding as internal development to work with the community using it. What we're thinking about and focused right now is how do we continue development of this ourselves, but also in partnership with others that are interested. And right now, we're actually adding non-network sources as well. Now, we haven't had syslog. We've just added syslog. That's something routers do, but it's also something that the rest of the stack does. We are really adding telemetry, as I mentioned, so that we can run 100 nodes of this in a big distributed network and understand how it is performing to collect telemetry. And right now, people install this manually on each location, and we're seeing a lot of demand to let Kubernetes manage it or otherwise help people automate the deployment and management of the translation. So, if you look on the left-hand side, adding logs and metrics from servers and traces and metadata, like being able to look into CMDBs, Amazon, Google, Microsoft, IBM cloud environments, and look at metadata about what's running where. Add that to the network data, so extending more sources of telemetry. We're going to be adding more things that you can do to filter, roll up, or shape, and then more destinations over time. And then, as I mentioned, more around the operability, and scalability. So how do you make it a package that you can deploy, whether you deploy it, for example, on an Arista at the edge or in a VM, otherwise, or on dedicated nodes, or whether you decide maybe I want to send all this centrally, have one big cluster that does all the work instead of doing some of the work at the edge. If you're interested, these are some links for it. You can look up Kentic Labs or Google K-Translate. We have a knowledge base page that shows some of the usage examples. And again, you don't need Kentic to do this. And in fact, on Kentic Labs, we have packages that will use K-Translate send things into Prometheus and Grafana, which we call Kentic Lite. We have agents that look at eBPF or PCAP on servers. So there's a bunch of tools that we've released, including even performance on Kubernetes that are at Kentic Labs, and I'd encourage you to look. We have a Discord for people that want to join, ask questions, get support. And if there are any Go programmers that are interested in working on telemetry, we're interested in collaborating, and we're hiring for this project with again all this work to be done in the open as well. So with that, I am happy to take questions. Would like to thank the community, I mean the internet community, but the Polish internet community as well, for keeping the internet going, which is really critical, connecting us. I know there's been a lot of work to help neighbors in this time, and it's a difficult time to be having a NOG, but the internet is really critical, and thrilled that the work goes on.